All right, welcome to today's video here. We're going to talk a little bit about, continue talking about functions, so get some more examples kind of based off of what we talked about in the last video, and then also talk a little bit about arguments. Now, one thing I want to caveat today about the arguments is that we're going to reference arguments based off of ESP, which is our stack pointer, and not necessarily always going to be the case. We'll talk about here in a very near future, we'll talk about the stack-based our base pointer, and so we'll have a stack frame and we'll be referencing our variables oftentimes off of that stack pointer, that base pointer, which is EBP. So this is more, at least in my mind, this is more of a setup for us to start talking about how we reference locations on the stack relative from one of our pointers, in this case the stack pointer. Okay, so that's really the main takeaway for the next 10 or 15 minutes or however long this video takes us. So functions and arguments. Alright, so we've used arguments before. You've seen in several of the functions that we've talked about that we need to either set up a register or we need to set up the stack. And that's what we're transitioning to talk about more. Function calls, and that in order to pass values to them, we're going to pass those values onto the stack. Printf uses the stack, scanf uses the stack. And so we've used, at least with printf, we've used them before, and that we have to push onto the stack before we call. Now, keep in mind that when it comes to calling something like a printf, and I'm just going to abbreviate this so that I can get it written. We have the first argument will be our format specifiers, and then our second and beyond, those arguments become the value that we want to print. And so when we pushed onto the stack, we pushed the last argument first and the first argument last, right? And so keep that in mind as we're going through these examples, that we will push in that order, right? The last argument is the first thing that we push, and the first argument is the last thing that we push. We'll be able to, at least for this video here, we're going to talk about how do we access those, or how do we reference those arguments when we're inside of a function. Well, we can reference them relative to ESP. So let's say that we have a stack set up, right? And maybe we've pushed some values on. So maybe I've pushed on 3, 2, 1 or something. So we just have some arbitrary values here, and then we call that function, and then we have the return address. Right? This is where ESP is pointing to, is right here. And so if I want to reference those values based off of ESP, then I can say ESP plus 4, or ESP plus 8, or ESP plus 12 decimal, or C in hex, right? And we just continue to go. We just continue to add ESP plus that value in order to reference that location on the stack. When we push, we talked about this in the last video, that when we push values on, we push them in a 32-bit architecture, we push them in, in DWORDs and 4-byte values. And so ESP plus 4 will give us that address 4 bytes off, plus 8 and plus C and so forth, right? So that's how we can reference those values relative to ESP. All right, so let's take a look at an example. Okay, so here's an example program in C. We'll take a look at the corresponding assembly and then trace through that. So we have, in our main function, we have two local variables, xx and yy. We run a scanf, or call scanf, in order to read values in. So we're going to, before we call scanf, right, we're going to push the last argument first. So we're going to push the address for y, then the address for x, well, yy, and then the address for xx, and then we're going to push this string value, this format specifier. Okay, then we'll call scanf. We'll get whatever values come in from standard in, will get put into those locations, and then we'll call function foo. Right, we're going to push yy, the value of yy, and then the value of xx, and then we're going to call foo, and foo will just simply return. Right, so we have x and y here. Right, so it just does x plus y times x plus y. Okay, and that's how that program will work. Let's see here. Let's try to draw through the stack as we call this function. Okay, so here's ESP. Here is an equivalent assembly program here. Okay, and I'm going to try to scrunch this up just a little bit. There we go. Okay, so here you can see, here's our format specifier. Use that for the scanf. Here's XX and YY. So declared those, reserved one D word, right? So res D is a D word, so reserving one 4-byte value, 4-byte location in memory for those two variables for XX and YY. So we reserve those in BSS because we're reserving them, but we're not initializing a value. So that's the difference there. Now we go into the main function, ASM main, and we can see that we're going to push YY, we're going to push XX, and then we're going to push the format. Right? Again, we're pushing these values on, and because when we push, we want to prefix that with the amount of data to read from this location. YY is just pointing to a location in memory. It just has an address, and so we want to make sure that when we say, right, push that address on, we push the entire 32 bits, 4 bytes, that D word. So that's why we're saying push D word. So go to this address and read 4 bytes of data at that location. In this case, that'll be that address there. So push the entire address onto the stack. All right, push D word XX, same thing, and then push D word for the format specifier. So we're pushing those 3 addresses onto the stack before we call scanf. So how that'll look, okay, so the address for YY, the address for XX, and then the address for our format. Okay, and then we'll have the function call. So by the time we call scanf here, right, then we'll have the return address on top of the stack. Okay, and this is where ESP will point at the time that we call. After we call, and once this works, scanf will do, will get the values from standard in and store that data into those addresses using that format specifier to determine what type of data to take in. Once that function, scanf, returns, then we've popped the return address off so it knows where to return to, which will be line 30 here in my sample code, add ESP 0C, which means that when we return to that instruction, ESP will be pointing right here. Okay, because we used the stack and now we're done with it, we need to make sure that we adjust our stack pointer back to the location that was previously at. So we pushed 4, 4, and 4. So we pushed 12 bytes on. Now we need to subtract, or I mean add, add to ESP that same, right? That same amount. So 3 pushes, 4 plus 4 plus 4 is 12, C in hex. So now we add that same amount. So now ESP will point back to where it was before that function call. Okay, and again, it's important that we do that, if we modify the stack, that we clean it up when we're done. Okay, the next thing that we do, and you can see from our original program here, is we call foo, passing the values from those 2 variables, from XX and YY. Okay, so if we look at that next set of instructions here, we have push D word YY. Right, so YY is a pointer, so we're using the brackets to dereference that pointer. We're getting the data at that location. So we're moving, and I'm going to draw. Let's just do a new stack. It's really the same, but because I don't want to try to overwrite over those locations, maybe. Okay, I'll just forget about that. I'll just continue. I guess we're stuck with purple today. And I don't watch sports, so that's not a hidden attempt to push favorite team colors or anything on anyone. Alright, so here's ESP. Okay, so this was our call to scanf, and this will be our call to foo. Alright, and ESP, at this point in time, ESP is pointing at the same location, right? This is the same stack. Okay, so now we push YY, so we're going to actually push the value on. So let's say I typed in 4, so we push that value on, and then we're going to push the value at XX, so I typed 4 twice, so now we push XX, and then we call foo. So we're going to push return address. All right, there we go. And ESP is now pointing here when we go to foo. Right, so now we're in function foo. How do we get those arguments? How do we get those values? Well, you can see that we move ESP plus 4 into EAX, ESP plus 8 into EBX. We add the two together and then we multiply. Right, so we can calculate based off of ESP. So we can say start at our base pointer and add 4 and then dereference that value and then move that into EAX, right, which is what we're doing right here. ESP is pointing to the return address. This is plus 4 and this is plus 8. Apologize, I don't know why this is being so difficult today. Right? So with the way that this function works, it really doesn't matter which order we access them. We're just taking each one, adding it to, adding them together and then multiplying. So it doesn't really matter there in this particular example, but that's how we're referencing those. So ESP plus 4 will give us, in this case, that gives us int x. ESP plus 8 gives us int y, because we push first thing. This is the first thing that we pushed right here. That's the last argument. This is the last thing that we pushed. That's the first argument. So this is like saying that this is x and this is y. Okay. Right, so we're getting that, moving that into EX, moving that into EBX, adding those together, and then multiplying EAX by EAX. Right, and then we return. So once we're done, we return. ESP is still pointing to the top of the stack. So when we ret from here, and we pop that address off the top of the stack, move it into EIP, ESP points now to this location, and we've returned to this instruction after our call to foo. Okay, we pushed twice, so now we need to adjust our stack pointer by 8. So we add ESP to 8. So now once we've executed that instruction, ESP is now pointing back to here, right, which is where it originally pointed to. Okay, and then with that, let's see, a print int, print new line, which just prints the results, and then we're done. We exit main. Okay, so we can run this program, and if we see 4 and 4, so 4 plus 4 is 8, 8 times 8 would be 64, and there's our results. All right, so it printed 64 with the new line. All right, I won't go through that same process here with this example. I'll leave that to you if you're interested, if you happen to be struggling at all with the concepts. To do that and use any of the techniques that we've covered now in the last 2 videos to try to make sure that you can follow what's happening with the stack. And if you run into issues, then let me know so that we can talk about it. This is going to declare a print string method. It's going to have one argument, that's a pointer to a string, and then it's just going to print that string using %s with a new line and then the string value. And you can see that I have that defined here in video 22, so I'll get this uploaded to our class folder. Here is that format specifier. Here is the value that we're going to print. Okay, so hello world, null terminated, %s, new line, null terminated. Okay, and now if we comment out the instructions, we're going to push that address of S1, which is what we want to print. Okay, so we're going to push that address onto the stack. We're going to call print string. Inside of print string, we're going to move ESP plus 4 into EBX and then push EBX, right? Because this is a printf, so we have to print that address. We have to push that address again, and then we'll push the format specifier. So ESP is pointing to the return address when we're inside this function. So ESP plus 4, we only had one push before that call, so that's going to give us that address. So we're going to push EBX, move F1 into EAX, push EAX. Okay, F1, if we look up, that's our format specifier. Right, so that's the first argument to printf. call printf, and then clean up the stack. Return, and then clean up the stack again. Okay, and then if we run the program, we'll see that we'll get the same results. I guess I gotta save it. Try that one more time. And there we go. Now it printed hello world, and because every time I pushed, I either popped or added, we didn't get any sig faults, right? Every time the program looked for a return address, it was on top of the stack and it was able to return. So there's some code. Again, if you want to trace through that, if you even want to kind of draw on here, that's set up so that you can do that. But hopefully it's starting to make sense. Again, if you have any trouble or any questions with this, let me know so that we can review it either individually or as a group. Otherwise, that is all I have for today. And we'll pick up next week. We'll start talking about, let's see, calling conventions and then EBP. So we'll be moving right along. All right, thank you. Talk to you guys then.